All right, so let's talk about clipping a little bit further into detail. So in the first video, I talked about, the introduction into clipping, overdriving the amplifier output. So what I did not explain was when you overdrive the amplifier output and introduce clipping by overdriving the output, what you are doing is asking the amplifier to produce a higher rail voltage than what it's capable of producing. So let's say an amplifier is capable of producing 100 volts on the rails. And that is, after the power supply section, it, transfers over to, from DC, and it converts it over to AC, through the diode network. So let's say the amplifier can produce 100 volts AC maximum current or maximum voltage on the rails, and then you turn the amplifier up to where it's trying to produce 120 volts of output on the rails. All right, so that's an example of overdriving the amplifier output. So let's see what that looks like here with the input signal versus the output signal. And I was just using that 100 volts and 120 volts just as a, imaginary numbers or whatever. That has nothing to do with this amplifier. So anyway, this OWON oscilloscope is connected directly to the speaker outputs of this Tower-Amps Chapeo 9K. So there's the probe, positive, negative. This oscilloscope, the Finersi 7-inch tablet, is connected directly to the RCA input. So I've got one RCA going into the amplifier, and then one RCA going into the probe for the oscilloscope. Now, base is a mono signal, so the RCA outputs from the head unit, it is one signal. It's not stereo. It is mono. So the signal going through this RCA is the exact same signal going through this RCA. And that's the way that it works. So that being said, we're going to we're going to send a signal through the amplifier, low voltage signal. And on this one, you can see right here, it's 500 millivolts per division. On this one, it's a 1X probe. As you can see right here, 1X. And then right here, it is a 100X probe. And it, right there, right there, the probe, 100X. And it's set to 100 volts. So, so right here, you can see this one is set to 5 volts per division. This one is 100 volts per division. So we're going to have low voltage coming in. The RCA signal is low voltage coming in, and then the amplifier does what it's supposed to do, which is amplify the signal. So we're going to go with low voltage going into the amplifier, and then high voltage coming out of the amplifier. So right now, we are volume 49, and this is 40 hertz on the DD1 track. Clean going in, clean coming out. So what I did was I hit the run stop button here, and then I hit the run stop button here, so it pauses the information on the screen so we can talk about it just for a minute. without overworking the amplifier and the battery and all that. So this is the signal going into the amplifier. You know, it's clean. It's smooth going up, smooth coming down. And you can see what it looks like here. Now the signal coming out of the amplifier, you can see it's smooth coming up, smooth coming down, so on and so forth. That's what you want. That is a prime example of exactly what you want to happen in your car audio system or home audio or whatever. Audio in general. But we're speaking about car audio. So, what happens when we overdrive the outputs of the amplifier? And that's what we was talking about in the previous video. So all I'm going to do, all right, so I'm going to unpause that screen. I'm going to unpause this screen. So now we're live on both oscilloscopes. So now all I'm going to do is going to go from volume 49 to volume 50, and that's it. That's it. So what that's going to do is it's going to still have a clean signal coming in, and then it's going to have a clip signal coming out. So I'm going to unpause the track, and then I'm going to hit the run stop buttons on both screens here. All right. So as you can see, the signal, it is still smooth coming in. Clean signal coming in. But up here, or over here on this oscilloscope, you can see that the signal is clipped. And this is the output, the O1, the yellow oscilloscope. That is the output of the amplifier. And it is a clip signal. We have clean signal coming in, clip signal coming out. So what is going on here is we are asking the amplifier to produce more voltage than what it is capable of given the circumstances. Now, if we increase the voltage, the DC voltage input on the amplifier, then that will directly affect the capabilities of the rail voltage due to how the PWM chip works with the transformers. And we can get a higher rail voltage with a higher DC input voltage, and then we can get more output. And that's going way more in depth than I wanted to on this video. But for now, let's just leave it at this. Clean in, clipped out, and all we did was go one click up on the volume. We didn't adjust any gains. We didn't adjust, there's no crossovers on the amplifier or anything like that. We don't have any DSPs or anything like that. Just using a head unit, sending a signal to the amplifier, and then here we go. So let's just end it right here, and we'll get more in depth on clipping in future videos. Let me know what you think. Give me some input, some feedback, some comments, good, bad, the ugly. Let's talk about it. That's it for this one.